Okay. If you want to look at them, take a look at your lower bounds. You're looking for lower bounds that are greater than 6.26 or upper bounds that are less than 6.26. Those will be cases where you've actually calculated an interval that missed that true population mean. And that should happen roughly 5% of the time. Out of a sample of 25, on average, only about once. Okay. So we see a little bit better what the sample statistics should act like. Let's take a look at review materials and start walking through this material, essentially reviewing from the beginning of the semester up until now, what might be on this exam. I put this material out here over the weekend. There's 3 things out here. The thing you should look at first is this midterm review. We'll look at this today. Second thing you should pull up is this practice midterm. The practice midterm is problems that are very similar to the kinds of problems that you could expect to see on the midterm on Wednesday. Some will be very close to what you'll see on Wednesday. Others are just the same general type of problem. There will also be something on Wednesday that really doesn't show up anywhere here, but you should be able to deal with quite readily with what you know. Okay, so
give us a little hint for what that might be?
Yeah, something not on this midterm,
Okay.
but something that you can handle. It's not something that I would expect anybody would have any difficulty, but we may not have looked at that specific situation before. So expect to not simply have the practice midterm with different numbers, is what I'm really talking about. I'm expecting that when you come into the exam, you'll be able to use some of what we've been learning and apply it to material. Okay? There's a set of solutions out here for this midterm. I strongly recommend that you work through the practice midterm without looking at the solutions. If you look at the solutions first, it won't help anywhere near as much. Okay? But they are here so that once you get stuck, you can go take a look at the solutions and figure out what I expect for an answer in those situations. Okay? So let's walk through the review slides. This midterm review is actually a set of slides. And I think I've caught most everything that's important out of this first section. So if we start with chapter 2, and these are more or less oriented by chapter as opposed to how the order of the material we went through. Turning data into information was chapter 2. We talked about categorical or ordinal data versus quantitative data. We talked about having single variables and the kinds of questions you can ask of those variables, the kinds of summaries that you could produce for them, and the kinds of graphics that would be appropriate. So for a single categorical variable, the only really thing that we can ask is how many are in each category. The kinds of summaries would be counts or percentages, and the kinds of graphics would be pie charts or bar charts. If we have a single quantitative, we can ask more information. We can ask about the location, meaning the center of the data. We can ask about spread, how far it's spread out. We can ask about shape. Is it symmetric? Does it have skew to it? Does it have 1, 2, or more peaks to it? In other words, unimodal, bimodal, or multimodal. We can ask those kinds of things. So there's a number of things that we can ask. Summaries would be things like 5-number summaries, means, standard deviations, interquartile ranges. There's a number of other things that we looked at. You should know what each of these are and how to interpret them. You should recognize things like if I gave you a distribution that was nicely bell-shaped, it's sufficient to tell me the mean and the standard deviation. But if the distribution is not bell-shaped, then I should be working with a 5-number summary, because the mean and standard deviation are only sufficient if I've got a bell-shaped distribution. Graphics, box plot, histogram, stem and leaf, those are the 3 primary ones. What is a box plot? Quick description of what a box plot is. Dan.
It's the box. It has your inner quartile, like your lower quartile range and your upper quartile range, and
Okay.
yeah, it shows the whole 5-number summary.
That's what I'm looking for. The box plot is the 5-number summary. It is the graphical equivalent of the 5-number summary. And that's all it is. From that, from either the 5-number summary or the box plot, you can get all the things that you're talking about. Okay? So the box plot is a 5-number summary. What's a histogram? You remember histograms?
I don't remember how to describe it, but well, or what it actually tells you. But I know that like isn't it adding up all the values within a specific range? So if you have like values from 5 to 4, and then or from 4 to 5, and then from 5 to 6 or whatever, then you add all those values up in columns.
Don't add them up. You're counting the numbers that fall within those.
Oh, okay, all right.
You going to say something? Okay. What it gives me is it shows me distribution, how the data is distributed. Okay. So a histogram is exactly what was described, a special form of bar chart that is ordered, that gives you the frequencies of occurrences within equal-sized bins. So I can see the shape of the distribution. Of these graphics, which one gives me the most information?
Box plot, right?
Box plot is essentially 5 numbers. Histogram usually got 8 or 9 bars, so there's usually 8 or 9 numbers at least there. So that's a little bit more information. What's a stem and leaf chart?
Shows the frequency of all the values.
Shows all the values, doesn't it? A stem and leaf chart has a character for every single data point. From a stem and leaf chart, I can tell you the shape of the data. I can calculate medians, quartiles, percentages, means, standard deviations, anything I need. It's all there. The data is all there for me to work with. Okay? That's one of the nice things about a stem and leaf. What's wrong with stem and leaf plots? Why wouldn't I use them all the time?
Sometimes there's too many values.
Sure. If I did a stem and leaf plot for a data set with 10,000 items in it, that would make quite a mess, wouldn't it? Okay? Which is why we have things like box plots and histograms. For 2 variables, so if I have 2 categorical variables, I can ask how many are in each subgroup as opposed to category. I can look at counts or percentages, either row or column, within those groups. And I can look at a grouped bar chart. A grouped bar chart is nothing more than a collection of bar charts. You have 1 bar chart for each category of 1 variable. Within each bar chart, then you have a bar for each category of the second variable. Okay? So it's just a combination of the 2. For a quantitative by a quantitative, that's our regression situation. The main thing we can ask is, do they tend to vary together? In other words, do they tend to increase together, or do they tend to go opposite directions? That would essentially be varying together, but in the opposite direction. Our summaries would be the regression line, and the R-squared value would be our primary summaries of this. And our graphics would be a scatter plot. Okay. It would be perfectly reasonable for me to ask you questions where I would give you a result from a study, a situation where we're going to do a study, something like that, maybe a research question from one of your projects, and ask you what an appropriate graphic would be for that particular study. Okay. You should be able to identify which of these situations it is and what the appropriate graphic it is to do that particular situation. Okay. The combined situation is the one where I've got a mixed relationship. I have a response, which is quantitative, and a explanatory, which is categorical. In that case, I can ask about the distribution within each category. The summaries are any kind of quantitative summary that's done by category. So I could do means, standard deviations, etc. by category. The key is that it's by category, not across the entire data set.